So the first half of this lesson, I want you to think outside the box. What are the ways that we can use energy better, right? Wind is there, and by adding a little shape to it, we can make that wind colder. And that didn't require any additional energy. Take a look at what's called a water main. And we're going to learn more about water sanitation and sewage. I'm sure you can't wait for that. We deliver water that's pressurized through these huge pipes. Why don't we attach little generators to them, right? Put a little turbine in there that as the water moves through, it also generates electricity. Not quite the same thing as what we call cogeneration, right? That's heat and electric from natural gas, but the same idea, really. If we're going to move water, let's go ahead and turn it into electricity. And look at this. Why don't we do it with highways? Have you ever been by the side of the road and a big truck comes by and you feel the breeze from that? What if we harness that? We're already using energy to move the vehicle, but let's not waste all that energy. Let's make it more efficient and reuse that energy. So these are designs that are happening now. That's not going to produce much energy. It's a very small source. But as cars drive by, it spins like a pinwheel. And it's enough to power streetlights, right? Especially with LEDs now that don't require as much electricity. Underneath highways, as semis drive under this, they're able to spin the turbines and generate, once again, electricity off to the sides of the road. And remember, part of the problem with fossil fuels is the carbon emissions. So we're starting to look at ways to take carbon out of the air. In fact, Elon Musk just announced a contest, right? I don't remember how much he's paying, but for the best design for removing carbon from the air. We've already been working on this for years. And there are some cool things out there. Architects have gotten involved. There's this fabric that we can manufacture in a lab, and it literally absorbs carbon from the air. And so they're starting to come up with ways to drape it over buildings so that our cities can reduce their carbon footprint. Our biggest issue with fossil fuels, we're making progress in the residential sector, providing electricity for homes. We can do that with solar and wind. We're meeting those demands. But the real big one is our transportation sector. For some reason, we cannot get away from oil. And it's because it's mobile. We can't carry around a wind turbine on the back of our car. That doesn't really work. Okay, so how can we provide enough energy to make vehicles efficient? That's the problem we've been struggling with now for decades. This might surprise some of you, but when cars were first becoming popular, late 1800s, early 1900s, there was an electric car. It was already invented. One of the first electric cars, 1896, was made right here in the United States. It's called the Riker. And there was a race. You can see the details there. He easily won every race he entered. He was beating gasoline engines. He was beating steam engines. That kind of blows my mind because we're just now getting serious about electric cars in the United States. We had them 100 years ago. We even had hybrids. A hybrid uses both electric and gas, but it's not a new invention. 1916, there were patents, and all that they had was a little lever that they could switch, and they could turn the gas engine off and switch to the battery. By the 1920s, gasoline was king, and unfortunately, we didn't understand hydrocarbons all that well. We were using something called leaded gasoline. That means it had lead in it. That's why you go to the gas pump today and your gas says unleaded, which they all say that now. Why do they even have to put it? Well, because it used to be leaded. The lead actually was better for the engines, but terrible for the environment. When you vaporize lead, it gets into your blood, and especially children can cause major developmental issues. So we finally figured that out, that lead was poisoning us. They stepped in with laws that said we had to set emission standards and regulate. Places like California, you have to get your cars tested to make sure they're not emitting too much of nitrogen or lead, sulfur. We notice a difference in lead in our blood levels that correlates with the decline of putting lead in gasoline. Huge invention, 1970s. By 1975, most cars were required to have the catalytic converter. I talked about this a little bit with coal plants. Not all coal plants use them, but remember what catalytic converters take out of the fossil fuels. They take out nitrogen, nitric oxide, NOx. Why is NOx so important to take out of the atmosphere? Sulfur causes acid rain. Nitric oxide causes smog. I'm going to post an Instagram about this a little bit later today, but people are now stealing catalytic converters from other people's cars. They'll sneak in overnight if your car is parked outside and they'll cut it right out. You get a metal cutter or a blowtorch and slice it right out. They're expensive. And what's inside are some precious metals, some rare earth metals, serum, platinum, and these have become quite valuable as emission standards have gone up around the world. Lawnmowers do not have catalytic converters. Gasoline generators that you can use for electricity on the go, those do not have catalytic converters. They're not required to. So if you go out and it takes you a half hour, an hour to mow your lawn, you're releasing nitrogen oxide into the air, worse than your car is. 1997, the first actual modern hybrid. So we went from 1916 to 1997 before these things hit the market again. It's got a brain and it calculates which is more efficient. Should I use the gas engine right now or can I run only on the electric? So it uses both. The other important invention here was that they figured out how to charge the battery when the car was braking. They could use the rotation of the wheels and the friction to create electricity to recharge the battery. So you don't have to plug a Prius in. A hybrid does not get plugged in at home. That's one huge advantage. The gasoline engine, when it's running, also charges the battery. This is a standard combustion engine setup, exhaust and all that. You got your catalytic converter right there. And one of the bad things about this, besides the pollution, is that you've got so many moving parts. That's one of the advantages of electric over gasoline, is less things to go wrong, right? All you need for an electric car is a battery and a motor. And that's why the Tesla is so attractive. Look how simple it is. You've got your battery and you've got your motor. In fact, they've spread the battery out now to make it bigger all along the chassis of the car. Now, everybody knows Tesla's pretty pricey. That's why we don't see as many of them on the road yet as I think we someday will. And there are other companies finally getting back in the electric game. But if you weren't picky, you can buy a standard basic Tesla for as little as $35,000. You can also buy Teslas that are as much as $124,000. They have ludicrous mode. I don't know what ludicrous mode means, but sounds great. Teslas are not without their potential flaws and critics. The batteries have from time to time been prone to fires. Some other disadvantages of electric cars are the batteries require rare earth metals. And so people argue that the environmental damage from building the electric cars is almost as bad as just driving regular cars and burning gasoline. Now, there's been studies done on this, and it turns out that most scientists agree electric cars do provide some advantage. Long trips are difficult. If you need to charge your car and you're driving across the country, you better plan your stops and know that there's a place where you can charge it, because we don't have the infrastructure yet in most places to conveniently charge a car. And think about it. If you're plugging it in, where does that electricity come from? If it's coming from a coal plant or a natural gas plant, we may as well just burn gasoline in the car, right? We're not really saving anything. So people say, I drive a clean car, and they plug it in their garage, and it's connected to the power plant, which is not clean at all. The irony here, a whole bunch of plug-in cars that are being charged by gas-powered generators.